We really appreciate it, and we're very excited to be here and very excited to have Palantir host our event tonight. Everybody give a big cheer for being here. Okay, I'm gonna see if I could actually click myself. These are our agenda for this evening. So we're going to have a lot of time. I'm not going to read through each item, but we'll have a lot of time at this event to do some networking at the end. So definitely, hang out. Don't leave in a rush, because we haven't had an opportunity to get to know all the members of the meetup as we have in the past. So we changed up the meetup this time around in order for us to do that. And we have some exciting announcements at the end of Madhu's presentation. So, definitely hang out. Ooh, see, I knew I wouldn't get it right. Oh my gosh. It's a weird click. Yeah, I think better if you do right and left. So I'm Donna. I'm our DC Spark meetup organizer. I'm also the VP of Operations and Services for MetaStream. We're a big data startup here in the DC area. I have shown some of these articles at the last meetup. So for those of you who attended last time, you're familiar with these articles. But I was interested in hearing how many folks here are really new to Spark and are just first hearing about it. Okay, great. And I guess everybody else is very familiar with Spark then? All right. So for the new folks, and for those who didn't attend the last meetup, there's some really great excitement around Spark. And these articles really speak for themselves, and that's why we're here today. We've been really surprised here in the DC area how many people are very excited and behind Spark already. And it's fascinating in talking to all of you guys how many companies here in the DC area are actually already using Spark. We're here tonight to do more of a technical deep dive, which is a little bit different than our last meetups. And we have a wonderful speaker, Madhu Siddalingaiah. We're excited to have Madhu because he's been involved in our meetups from the beginning. So we really appreciate him coming out to speak tonight. He is a Spark contributor, so he knows Spark intimately. And Madhu is also the co-author of Pro Apache Spark. Madhu, when is your book coming out again?
It's supposed to be today.
Today, okay, so how appropriate, right? Okay, exciting. So, and how are people going to be able to find it?
Go to Amazon, you'll see it right there.
Okay, fantastic. And on his off time, when he's not coding and writing like crazy, Madhu is a helicopter pilot, but he's going to tell us more about his background and maybe some of the interesting flights he's flown. And you're up next, Madhu. Okay. You need to do right and left is better because these are not sensitive enough.
All right, so we got to do full screen.
Oh. Where is the, oh, here it is.
Yeah. There we go.
And there you go.
Fantastic, fantastic. What a wonderful group. Wasn't that fantastic introduction by Donna? Okay, so before I get started really quickly, so we heard about the people that are new to Spark, so I say about a third of the people. How many people are actively using Spark? Maybe another third. How many of you are experts in Spark? Okay, good. Nobody's lying. Good. All right, excellent. So I wouldn't consider myself an expert either because they say expert takes 10,000 hours, and I don't think Spark's been out for that long, so I don't think anyone could claim that. Although obviously some of the people that have been developing it, they started many years ago. So there are, it's pretty interesting. So I'm gonna sort of aim this down the middle. If you're new to it, you'll get something out of it. If you have some experience with it, hopefully you'll find something interesting. If you're an expert, have another beer. Okay. So I'll just tell you a little bit about me and a little bit about an introduction of why we're here, why Spark is here, and why I think it's interesting. So a lot of it's from my perspective. So you're welcome to agree with me, disagree with me, but you know, it's just what I've gotten out of it. And I do have some opinions about a lot of things. So you'll hear about that. And I'll get into a little bit about the Spark internals. You'll see a lot of it on the web about, well, it's this, it's that, and it's a lot of hand waving. But you know, I've gotten deep into the source code, and I don't know everything about it, but I've learned enough, and I was able to contribute enough and add enough to it that I say, you know what, it's something that is approachable, and that's a big part of it. And I think what's really important in open source is to have things that are approachable. Okay, and I'll talk a little bit about the development process. You can find a lot of this material online, but it's not always easy to find, and I'll show you sort of like the easy way to get in there and do it. And then I'll give you a quick summary at the end. Okay, so a big thing about who am I, what am I, you know, people ask me this, what do you do, who are you? I have no idea, I don't know. I just do what works for me, okay? So back in the day, long ago, there was this university out there, Maryland, and I was there, and if you were there, great, and that's done. But I had a physics degree. Why? Because it's a long story, but it was easier than getting an engineering degree. That was pretty much it. But actually, it was a great thing. At the end, I think it helped me considerably because I got into a lot of math, I got into a lot of modeling, and so I got into a lot of heavy science. So there's this thing they call data science, which is kind of the same thing. You just do it with numbers instead of like physical objects. So it fits well. So you see that picture, that thing in space. That's actually there. I worked on that project. It's in space. There's some crazy ideas, crazy things that came out of that. And in fact, believe it or not, that one project, we used to have it up at GE Aerospace, and we had to drive it back, and I actually drove it back with the vice president's son at one time, believe it or not, my 15 minutes of fame. And I'll tell you one quick brief thing about that. So we were both driving this Ryder truck, myself and Tucker, and we drove it all the way back down, and he was halfway down. He says, hey, do you mind, you want me to drive? And I said, no, it's okay. Remember, he's like a 18-year-old kid at this time. And at the very end, I asked our commanding officer, he said, Tucker asked if he should drive the truck, and I kind of said no, because I didn't want to wreck the truck. It's like he drove it and he wrecked the truck. It'd be on the front page of Washington Post. It wouldn't look good. But he said, yeah, don't worry about it. It's not that big of a deal. But so that was an interesting project. It's out there. It's in orbit right now. It's collecting data. So first third of my career, I did mostly engineering, signal processing, worked for these big companies and all that, and I thought I would really enjoy it. But eventually, I sort of got into the internet age in the mid-90s. That first book there is one of the first books I published, the Java How-To. That's just because you heard about it. You heard about that tech bubble thing? Maybe you heard of it? Well, that started around mid-90s, so I kind of rode that wave, worked for all these big companies, and did a lot of consulting in all those years. Did a lot of work in healthcare. I did a lot of work for Apple Computer, Sun Microsystems, the DoD, of course, which is in this area. So primarily what I did was consulting up until about 2011, and there's where I sort of stumbled into big data. Notice there's a lot of stumbling in my career. So I stumbled into big data, and how did that happen? You see that board down there. It's not exactly the board that I worked on, but a friend of mine who was my professor at the University of Maryland, I said, hey, why don't you help us with this high-speed I/O device that has 4 terabytes of flash storage, and it's got specialized hardware. Why don't you come work on this thing? And pretty soon I realized, this is a big data product. They had it for, they were selling it to a very special agency, but it turned out that it was a big data product. And these are engineers. They didn't really know what big data was. So we started getting into Hadoop. We started getting into other ways to make this useful, and they're trying to turn that into a commercial product. I left that company in 2013 and went to FINRA, which is a financial regulator that's up here in Rockville. They collect market data, about 3 terabytes of market data a day. And they comb through it looking for doing what are called surveillance patterns, among other things. And that's to look at the market data and making sure that everybody follows the rules and making sure that the market is something that people want to use and they can trust. So that's an interesting thing. So what I do is the front end when the data comes in from the exchanges. And you see those two exchanges right there, Direct Edge and BATS. Those are about 1/3 of the market. So 1/3 of the market is handled by New York. The other third is NASDAQ, and Direct Edge and BATS are about another third. And BATS purchased Direct Edge recently, so really they combine. So I led a couple of those projects there to onboard those systems, and they're in production now. Primarily, that all uses Hadoop, mostly Hive, MapReduce, but we are migrating a lot of that. We're looking at Spark because of its performance, and it's just cool. I think it's cool, right? And finally, there's the book on the end, which is that Donna just talked about. That's supposed to be out today, but it's not. So you can go and pre-order it, and maybe you'll get it. So Samir is another colleague of mine. He works also at FINRA. He works on a different team. So that's that. Enough about me. All right. So let's get into, so you guys all heard this, big data. You all know what it is, right? It's big, it's a lot of it. There's tons of data out of there. A lot of people are producing it, and there's a lot of value in it. So that's pretty obvious. So how do we deal with it? Because obviously traditional approaches don't really work very well. They don't scale well. So we need better ways. And I'll show you this picture here that explains why it's important. Because it's not always clear why it's important, right? We've had a sort of a free lunch for the past, 40 years or so. Because even in the 60s, people thought about, well, scale is a problem. How do we make computers faster? And people thought about parallel processing, and you read the early papers, they exist. People they were thinking about parallel processing back in that time. But it turned out nobody really cared because there was this company called Intel, and there were all this place called Silicon Valley. And they turned out to be really, really, really good at making things faster and faster and faster every year. You've heard of Moore's Law, double the number of transistors on a die every 18 months or so. That was the prophetic prediction by Gordon Moore, and it was actually surprisingly accurate. Why? Just luck. Dumb luck, I think is what it was. I don't think he knew what he was talking about. I think he just made it up, and it just so happened he was right. And if you look at that green line there, it pretty much follows about every 18 months, double the number of transistors. So we had a free lunch. So we as software developers could just write whatever we wanted. It didn't matter. We could write the worst code in the world, and next year it would be twice as fast, right? So that's basically what happened. But you see over there that blue line? Around 2004, the free lunch ended. Why? It's not because of the number of transistors. It had to do with power dissipation, other device physics, other issues. So it is going to come to an end. Things can't get better forever. So that's pretty much where it happened. So it's sort of flatlined. So what happened at that time? Yeah, there are more transistors on a given die, but we have multiple cores, right? So we don't have faster processors, we just have more of them. And so now that means we got to think about things differently. We can't just write the same code we used to before and assume that it's going to get faster and write even worse code in the future and assume it's going to work just as well. So that's an important development, all right, and a subtle one. So we